Hello everyone. Do you want to learn how to connect Aspen Hysys with Excel and vice versa? I'm sharing the training video from my process design course. Please do watch, learn, subscribe, share and like. Thank you.
So next section is how to connect Hysys with Excel, meaning you type some input parameters in Excel, click calculate, and that value should go to Hysys file, run it, and again come back in Excel. You want to learn how to do it? Let us do it. As if you have any choice. It's part of the syllabus. You have to learn it. So if you go to session 0 folder, in session 0 folder, we have VBA literature. In that, yeah. So please go to this path, and we have got two files here. One Hysys file is there and one Excel file. You need to open both the files. Other Excel files, you can close it. Okay, save it and close it. So this file is the V11 version. So I think everybody should be able to open it. Please open both the files, Hysys as well as Excel. If you don't have it, please tell me. I'll share it in Zoom chat. Done. Jagan already shared on Zoom chat. Check. Once both the files are open, write O in the chat box. All right, please look at my screen. So I opened the Excel file, case A Excel, and I'm in this introduction sheet. So it says that there may be several methods to deal with below issue. I'm suggesting just one of it. So it has got annexure 1 PFD, okay, which is this. The yellow things, it is all input parameters that you can change, right? I'll just make it half. So right now, left side I got Excel file. What is the temperature of process fluid in? There is a shell into heat exchanger. Shell side we have process fluid, which is basically gas, methane and ethane. Okay, 40% and 60%. And from 75 degrees C, I want to cool it down to 50 degrees C. Cooling water inlet and outlet temperature I have given as an input, correct? And I am calculating what is the cooling water flow rate. See that? And what is the cooling water flow rate right now? 6107 kg per hour. if I change the flow rate, sorry, temperature from 75 to say 65, and then click here, link to Hysys, you can see a temperature change to 65. Because of that, cooling water requirement reduced. Now it is 3630. Same value you can put it, you have got it here. So how these values are going from exported from Excel to Hysys, and from Hysys, how those values are getting imported back to Excel. Okay, so there are codes, of course. So first step is you need to prepare the Hysys model. Okay, and then you need to draw something that looks like your Hysys model. And whatever value you are planning to change it, you can just put it here in yellow, right? And then you can see there is input table in the Excel file. So it is always better that the VBA codes receive all the input parameters from one place. Okay, so whatever input parameter that we have used here, typed here, so those are all the formula we are given like this. Say annexure 1 PFD F7. What is that? It is 65. So this 65. So F7 of annexure 1. So like that, all the values, cooling water outlet temperature, cooling water outlet temperature. You see here in D10. So we had D10, cooling water outlet. What happened? Sorry, H17. So H17 is this, right? 40 degrees C. So if we change this number, it will go to annexure 2 input table. And then as for the code, it is going to take all the numbers from one sheet, which is input table. Annexure 3 output table. So all the values, those are calculated in Hysys environment. So those will be the required value whose code we have written. So those values would go to annexure 3 output table. And let us say we have 3629.3630 flow rate for the water. What is that? It is F6 of annexure 3. If I go to annexure 1, this value is being copied from annexure 3 F6, right? So you don't have to jump from one window to other window. At one place you will get all the numbers. And then these are the codes, VBA codes. And this is the snapshot of Hysys. So when I done this, it was version 7.3. Into this, nothing. Now, if I go to input table, so you can see here Hysys path, Hysys file path is there. Where it is? It is in B2 cell. Okay, so if you see here, this is the path where I have saved this Hysys file by the name ksaxl.hs, meaning this file path in your system would be different from what you see on the screen. So please find out the location of this ksaxl.hse file and then copy that and paste it here. Please do it. Annexure 2. So in my case, this ksaxl.hse file, it is available here. So I'll copy it. Okay, once I change the Hysys file path, right, done in the chat box. So from the developer tab, I go to Visual Basic. Okay, so these are the codes that you can see here. Okay, please look at my screen. So I am in module 1. It says green line, which is a comment. Below 3 lines shall be same in all the cases. So option explicit, public HY app, then public sim case as simulation. So this is not going to change. Then again, comment. Taking reference from worksheet annexure 1 PFD, prepare a HYSYS file. Snapshot is saved in annexure 5. This clear? Then we have first define the strings, preferably all the strings in your HYSYS file, right? So public pf underscore in as process string. So in HYSYS you can see this stream name is pf underscore in. Okay, this one is pf underscore out. This is cw out, cw in. So all these process streams you need to define. Okay, public pf underscore in as process stream. Then only this VBA would know that we need to treat this as a process stream. Similarly, pf out as process stream. Similarly, cooling water in out as process stream. The next is public. The subroutine name is start HYSYS, right? What does it happen here if you go to annexure PFD? If you change this number, okay, you remember I had clicked here, link to HYSYS. So this is linked to this macro. Okay, what is the name of the macro? Start HYSYS, right? You remember we had done the rectangle for the goal seek, and we had given right click, assign macro, and we are given macro 1. Okay, that macro 1 in this case, the name of the macro is start HYSYS. Okay, that's the only difference. So start HYSYS is your macro name. And this thing will be pretty straightforward. You need to provide the stream dimensions. So you can see here, PRES pressure, PF underscore in as double. Flow, PF in as double. Temperature, PF in as double. Meaning you are trying to provide temperature, pressure, flow rate for the process stream. And then dimension composition as variant. Okay. Now don't ask why as double, why not as single. Okay, why as variant. So you need to follow as it is, right? Um, so this is little different. Okay, I added this. We're going to skip it. Then loading HYSYS simulation file. So this will open your HYSYS file as per path provided. So where we have given that path for that HYSYS file, here it is in B2 of annexure to input table. Where is it? Annexure to input table. What is the path? B2. Okay, so that is how HYSYS VBA would know which file we need to open. But if it is already open, then it will skip this. Then we need to set all the strings. Okay, like this. Set pf underscore in as sim case, simulation case, flowsheet, material stream, item. Okay, similarly, all other streams should also be set. Then export data from Excel to HYSYS. So with this code, we are going to input data from Excel to HYSYS. So what are the things we can do the input? Composition, right? Then ambient temperature, these are the codes. Then this is temperature, how to set temperature from Excel to HYSYS. Then we have pressure, then flow, and export data from HYSYS to Excel. Now calculation is done in HYSYS. We want, let us say, temperature. Then what are the codes for temperature? How to get the temperature from HYSYS to Excel? This is the code. And where you want to save it? In annexure 3, range D6. We need to save it. Okay, and what we're going to save it? Cooling water, temperature, get value C. C means degree C. If you want it in Fahrenheit, so it will be F. If you want in Kelvin, it will be K. Now there is again a comment here. It says, although it is not an input parameter in this particular project, it could be in some other project, right? So it is better to learn the code. Same thing is for the flow, pressure, mass fraction, mass density, viscosity, vapor fraction. So these are typical parameter that one would require. If let us say you don't want the dynamic viscosity, you want kinematic viscosity. So you can study the present code and then try to edit. Instead of writing say viscosity, you will write kinematic viscosity. And instead of writing say centipoise, you will write centistokes, correct? Or meter square per second. Make sense? And if that doesn't work, even after doing all the combinations, you ask Aspen support. What is the code for this? Clear? Okay, now uh, please go to annexure 1 PFD. Then change the temperature from 75 to 65 and then click link to Hysys. So I assume that you already changed the Hysys file path. Okay, once it is done, write the cooling water flow rate in the chat box. Should be 3630. If any query, please ask. Okay, you can see 4, 5 answers. What about others?
Sir, this ISIS file is not opening in my case.
Okay, you have to share the screen.
So how
Yes.
to enable macros?
How to enable macros.
In options?
Okay. This is probably the topmost level of Excel expertise that you're talking about, and you're asking about how to enable macro. Really? Who asked? You didn't get the name.
Of me.
Kunal. Okay, I'll come back to you. Yes, sir. Dharmara, what's the problem?
The file is not opening ISIS.
Okay. What does it say? Where is the file, sir? The .hsc file you have to put, right? So that is missing. You have put everything, replaced everything itself. Okay, so copy. This will be forward stroke. Control V dot HSC. Okay, go back and then to hashes. It says may not be available. All right. So developer tab. Kunal, please see what I'm doing. Macro security. It is already enabled. So what I'll do, I'll close it. So save it, close it. So where is this file located? Is it this file?
Yes.
Okay, so right click, then go to properties.
Unboxing, I already have done that.
The unboxing is Kunal. Do you have anything, any checkbox that says unblock?
That I already done, sir.
I'm asking Kunal. He's also having same issue.
All good, all good.
Is it working, Kunal?
Now, no. Yeah,
To Hysys. All right. So this issue we can resolve. Click OK. So you are using V11, right?
Yes.
So here V14 library is there, but since you don't have V14, so that's why it is saying where is V14 library.
Okay.
So Aspen Hysys library, you need to search here. Hysys. Yeah, Hysys 11. Then click OK. Then reset it. Then close it. Then click link to Hysys. Okay. And something else is missing.
So probably the Hysys file is closed. That's why it is happening.
Hysys file is supposed to open. Okay,
But
even if
that
it
is
is
not
closed.
open, I guess. But in
No,
this case, I think the file is not open.
no, it doesn't matter. If the file is not open, you can see here. This will open your Hysys file as per if Hysys file is not open already.
Oh, okay.
If it is
Okay.
already open, then it is open. Let us run it again. Okay, now it should work.
It's working.
Uh, how come your version is lower version? Okay, Anshuman, you have V11, right? Anshuman,
Yes, sir. Yes, sir.
you're sending the file.
Yes, sir.
Okay, anyone else who did not get it?
And PF1 is 60 degrees and 6000 kg per hour. These things we need to set.
Anything that is yellow that you can change input.
Yeah,
And then you
I
can
changed,
run it.
but I see 3630, but I don't know what is this number. I'm trying to find out.
Hello, sir.
Yes, sir. Yes, sir. Working. So you have changed the path for the new file.
No, sir, just downloading. Sir, pop-up is coming. Microsoft Excel is waiting for Aspen Hysys to complete an OLE action.
Okay. Maybe you clicked something many times. Let's cancel it. Let us see what happens. Debug it. Object. So this is how you reset it. Let us see the code. What you have written. Input table. So where is that?
This is done. Yes, download first file. Yes, this one.
This one, right? One second. So this download, I'll just copy and put it here. So that's the location. Then link to Hysys.
Sir, actually path should be copied from the properties. You have to right click on that Aspen file. Yeah. And go to properties. You can get the location below the, yes. You have to copy this and paste it.
Okay, one more try. All right, Jagan, for you it is working.
Yes, it's working now.
Okay, can you do one thing? In your Hysys file, just save as .xml file.
You're asking me?
Yeah, Jagan, to you.
Oh, yeah, okay. I'll save it as a
Save as
dot
that .xml.
Yeah, okay.
And that .xml file, you please share it in the Zoom chat.
Okay.
Why this window is not going?
What I'm active.
Just 1 second. It's not responding. Probably it's because of the macros are connected to Excel. Okay. Save as.
All right. Can you open Hysys application?
I shared it.
Thanks. Yes, Samaraj. So that .xml file, you can just drag it onto this, or you can open via this also.
Now it's open, sir.
Okay. So change the number, click link to Hysys. You need to make it active first, right side window. Make it active. Okay. Now change the temperature and see what happens. Click link to Hysys.
What, sir?
Click link to Hysys.
Reflecting here.
Will get changed. Okay.
Yes, yes. No.
Yeah.
It didn't work, no? Okay. 4356. Do we have 4356? Yes, it's working.
Yes, sir.
All right.
Okay, thank
So there
you.
is something else also you can see here. Okay, that I will let you explore on your own. Something additional thing I have done here to find out heat loss to the ambient. Clear? So we can save it and close it. Any query you have for today's session?
So one query I have, sir, are there any good resources for learning VBA? Because this also will we learn, but I don't think at least I would be able to replicate it for any other HYSYS problem. So just wanted to learn VBA. So are there any good resources for learning VBA? Probably there is something in the S0 folder.
Yeah, it is there in S0 folder. But whatever we have covered, that is more than
Yes.
enough.
Okay.
So basically, the peak point of HYSYS or rather VBA is how to connect HYSYS with Excel and vice versa. Right? I'll just try to open one file.
And is there any way like we can create the HYSYS as a DLL and we don't, when we run from Excel, we don't open the HYSYS, but it runs as like a completely from Excel, like a.
I don't believe that is possible. You have to have
Okay.
HYSYS application.
Okay.
The example what you have seen now, so that is the base example. Okay, it is very simple to understand. But you are not really going to have only one shell and heat exchanger, correct? You will have something more complicated. So we have this, let's say, fractionation column. Right? The codes are the same. Okay, so, but in this example, there will be a little more number of codes. So what I had done, this fractionation column, which was there in Qatar Chemical. Okay, so that I had modeled. I had prepared the HYSYS file for that. Okay, which has got many things. I made sure that this results are benchmarked with something known. What is that something known? The design case. Correct? So once that is done, that part is done. If I change some input, the results I can trust. Okay, and then coding was done for the operating case. All this PV means the pressure value, and then the flow rate, etc. So that is coming from there. They had one PI system, plant information system. So whatever operating values of the parameters were there, so those were reported. Okay, for the given duration of the time. Okay, we can also pull the historical data also from that PI system. So when we know the input parameters, pressure, temperature, composition, etc., and we want to send these input parameters to HYSYS file and get the results. And when we get the results, we need to check whether the wall opening that is there at present, whether it is more or less matching with the HYSYS results or not. Correct? The purity of the top product that you see, whether it is matching. Right? So the orange thing you can, sorry, the purple thing what you can see, it is from HYSYS. It is coming from HYSYS. And the orange is from PI, Plant Information System. Now, where this will be useful? First of all, to get more confidence on our simulation model. Okay, and if you are doing this for say several days, and if you are getting the answer benchmark with or answers matching with the operating data, then instead of doing some changes, trial and error in the plant, which nobody would allow, you can change things in the model itself. So instead of operating the column at a certain pressure, if you increase or decrease that pressure, okay, you play with the reflux ratio and see what happens to the column top product yield and the purity. If results are promising, you can suggest that to the plant people, correct? So this is to get the best operating conditions for the given plant, so that you get more yield, better purity, and finally more money out of the same plant. This makes sense? So your objective target should be, you should be able to prepare such a file for your plant. Okay, don't go for the entire plant in one go. Take one section at a time, get it converged, okay, get the results benchmarked, then move to the next, then next, then next. Correct? So to get this, you need to start with the earlier case, shell into heat exchanger. Okay, PF in, PF out. Make sense? So if you are able to achieve this target, I think you don't need any other VBA coding. That is more than enough, trust me. And if you are able to prepare something like this, and if you show to your boss, okay, so there is no surprise who will get the next promotion. So as an employee, and now this is not technical, as an employee, you should always give more than what has been asked. Okay, so if you are being asked, I'm not talking about the number of hours you spend in the office. Okay, let that be 9 hours or whatever. But in those 9 hours, please make sure that you give maximum. Right now, this particular project, nobody had asked me to do that 50 problem list. I told you, right? So those are my. I was getting paid to do those jobs, not for this. So this I did it on my own. I presented to the plant head there, and he liked it, and he gave me other plant also to do the similar simulation. Okay, once that was then ethylene plant, and it worked well. Now also they are using the same, right, for studying it basically. Okay, not for optimization, because these guys they are very scared to change anything in the operating plant, right? Interesting. So you
Yes,
want
sir.
homework assignments for your plant? Okay, this you need to do it on your own. All right, so this is what I have for today. It's about 4:30. For some reason, Sunday batch we finish 1 hour before as compared to Saturday batch. I don't know what is the reason. You guys do not ask enough questions, it seems. All right, learn something new today, Dharmaraj?
Yes.
Yes, yes.
In the next session, we are going to continue with our process dossier. Okay, so we'll prepare cause and effect, operating control philosophy, line list, equipment list. We'll learn how to do the HAZOP. Okay, although it is not our deliverable, but we should know how HAZOP chairman conducts HAZOP, so that during HAZOP session, we'll be well prepared, and we'll have minimum or no recommendation from the HAZOP chairman. Okay, so that we'll do, and also we have FlareNet, so that also we'll learn, and you will learn how to do the PVRV sizing, pressure vacuum relief valve sizing, using Excel as per API 2000, and also using Hysys, right? So two simulation, uh, different simulation software we're going to study next in the next session. All right. So kindly provide your feedback today itself. We want to share the feedback tomorrow.
Yes, sir. Sir, I have a project problem. Can I discuss that?
Yes, yes, please.
Okay, sir. I will share my screen. Sir, my
Do you
screen
want
is
to
visible,
stop
sir.
recording?
Yes, sir. Yes, sir. Sure.
No, it's up to you. You want me to stop recording or no?
Yeah, sir. We can stop. It is some other project data, so it's good to stop.
All right.
Okay, sir. Thank you.
All right. Any other query anybody has? All right then. Thank you very much, everyone. Please do not forget to provide your
Thank you, sir.
feedback.
Thank you, sir.
All right,
Thank you,
thank
sir.
you.
Thank you.
Thank you, sir.